Welcome back. So as mentioned, there's a difference between weather and climate. So now we're going to talk about the things that control a location's climate, that determine a location's climate, that shape the climate in a certain area. So there are six what are called climate controls, things that control the climate in a certain area. Latitude, elevation, ocean currents, wind systems and wind patterns, the proximity of locations to water, and the topography. Now, we'll take some time to explain all of these, so we'll cover about 2 a video, so this session will probably most likely be broken up into 3 different videos. All right, so let's first, in this first video, we'll tackle latitude and elevation. So, latitude. This is an important one. So latitude, again, is a measurement of how far north or how far south of the equator you are. So the equator is this fictitious line that runs around the center of the Earth, and how far north or how far south really helps to determine and dictate the climate. Think about, places right around the equator, what their climate's like, usually warm, tropical. When you get further away, obviously the furthest away you can get from the equator, it's much colder. So there is differences as you move away either north or south from the equator. So here's some examples, and these are the 3 blue dots that were on this. So here's something right along the equator in Africa, kind of right on the east coast of the US, and it looks like northern Russia over here. So we have Zaire, Africa, so the east coast, Virginia in USA, and Yakutsk, Russia. So there's differences here. These are called climographs. The information here, we have latitudes and longitudes. We have elevations. The blue indicates temperatures. The blue indicates precipitation. Now, precipitation doesn't mean just rain. It could be rain, snow, hail, sleet, any type of water falling from the sky, and as well as the months of the year. So you can see in Zaire, with about 0 degrees latitude, right on the equator, the temperature stays pretty constant, pretty warm. This is in Celsius. So it stays pretty constant and a lot of precipitation throughout the year. In the East Coast, Virginia, all right, so they have kind of cold winters, hot summers, right? So warm in the summer, cold in the winter. It's kind of normal when we think about weather, and some gentle precipitation all year. And then Yakutsk, Russia. Look at this big difference. So warm in the summer, really cold in the winter, and just a little bit of precipitation. So the biggest thing with latitude is how much the temperature ranges, or how much the temperature changes throughout the year. Around the equator, temperature pretty much stays constant all year long. A little bit further north, 37 degrees north of the equator, we get some fluctuations. 62 degrees north, even further north of the equator, much bigger temperature range. That's the difference between the highs and the lows. The same thing happens south of the equator, so it's just how far north or south. Well, the reason is this. When we have the sun's rays, that solar energy hitting the Earth, that's what's giving us that warmth. So we have, again, let's just pretend the sun's giving us 3 rays here and 3 rays here. The same three rays of the sun's energy. When they hit the equator, you can see that they kind of just all hit in this small area. So that solar energy is concentrated. The energy is concentrated there, meaning it's going to be warmer. Well, up here, it's the same 3 rays, but you can see by the time they hit different parts of the Earth, it's kind of spread out over a larger area. That solar energy is more spread out. So instead of being just concentrated, it's more spread out. So that energy is more spread out, therefore less heat. All right. So same amount of energy is hitting a smaller area, so it's concentrated. It's going to be hotter. Same 3 solar rays, but that energy is spread out over a larger area. Therefore, it's going to be a little bit cooler. You're not going to get as intense heating the further you get away from the equator, north or south. And this purely is dependent on where you're at on the Earth. Or in other words, your latitude, how far north or south. It is actually the main influencing factor of any climate of a region. There's those other 5, but this is definitely the main factor influencing the climate of any region. And that's because different latitudes receive different amounts of solar radiation. Some places it's concentrated, some places it's more spread out. It also influences precipitation, as evaporation is temperature dependent, more more on that later. The equator receives the most solar radiation, therefore it's going to be warm, wet, small seasonal temperature fluctuations. Polar regions receive the least solar radiation, so it's pretty much the opposite of that, cold, dry, large seasonal temperature fluctuations. So let's again look at some cities, one in South America, right on the equator, one in Europe, a little bit more north, and again, I don't know, Yakutsk, Russia. So again, you can see it really drives the temperature fluctuations, the temperature ranges, I should say. Around the equator, so around 3 degrees south of the equator, so pretty much right there, little fluctuation. 42 degrees north, so a little bit further away from the equator, you get some temperature ranges. That's the difference between the highs and the lows. Even further from the equator, much bigger temperature range. So again, latitude is the main driver of climate of a region. But there's also these other 5 things that can be a factor, that can influence climate. All right? One of those being elevation. Elevation is a measurement of how high above sea level you are. All right. So temperature generally decreases with higher elevations. Here in Arizona, think about Phoenix and Flagstaff. On the globe, we're pretty much, let me get the globe actually, we're pretty much at the same latitude. I mean, Flagstaff is a little bit more north of the equator than we are, but we're, as far as the Earth goes, we're pretty darn close. Here's the equator, right? Here's Arizona. So the latitude difference between Phoenix and Flagstaff isn't much. But why is it so much cooler? Well, it's at a much higher elevation. Elevation, though, more greatly affects the minimum temperatures than the maximum temperatures. So you typically get lower lows, meaning in the summertime, it's pretty hot here. It can be pretty warm in Flagstaff. It's not going to be 110 degrees, but it can get up to like 90 degrees. But in the wintertime, you know, it'll be 50 here, and it'll be like 20 there. So you're going to get much lower lows. So the highs, yes, Flagstaff has lower highs, but their lows are going to be even lower. That elevation generally, again, gives you a more of an effect the minimum temperature than the maximum temperature. And that's because as elevation increases, the atmosphere becomes less dense and temperature decreases. There's just some physics involved there, but again, the reason being, if we're lower in elevation, the atmosphere is more dense, so the atmosphere itself can kind of retain more heat. The higher in elevation you get, the less atmospheric gases there are, therefore the less chance of retaining heat, so cooler temperatures. And elevation affects both yearly as well as daily temperatures as well. So here's an example. Here's Denver, Colorado, and where that red marker is a town called Evergreen, Colorado. Evergreen, Colorado has an elevation of 7,200 feet. Denver has an elevation of 5,280 feet. That's why it's called the Mile High City. That's how many feet are in a mile. These two towns are only 18.5 miles apart. That's like from Avondale to Phoenix. It's not that far. Right? This is not that far. But yet, it has almost about 2,000 feet in elevation higher than Denver. Evergreen does than Denver. So how does that, again, affect temperatures? So again, when we're looking at the differences, so the red is Denver, the orange is Evergreen. So Evergreen, this is elevation, higher elevation, Denver, lower elevation. So when we're looking at Denver, it's lower elevation, so it's warmer. Here's Evergreen in the orange. So obviously Denver has a higher high. But look at the difference here, this gap here, versus the lows. Whereas Denver is here and Evergreen's here. It's a much bigger gap. It's a much bigger gap. So this is, again, where elevation more affects the lower temperature. You get lower lows. So if it wasn't for that, then this orange would kind of be up here, about the same distance as these highs. But in higher elevations, you're just going to get lower lows, colder cold, essentially. All right, colder colds. You can see in the wintertime, Denver and Evergreen, so this is summertime, in the wintertime, January, February, or November, December, they get about the same high temperatures, but yet Evergreen much lower lows. Oh, and this is throughout the day, and this is throughout a general day. So again, not only yearly, but daily as well. So again, the highs are here, but the low, you can see the difference between the lows here. So much lower lows, much colder colds. So here's an example, keeping latitude constant. So we have two cities about the same latitude, right around the equator in Africa, but one's going to have a much higher elevation, one's going to have a much lower elevation. So at Uganda, you see the elevation is well over 1,000 meters. In Somalia, the elevation about 6 meters. Latitude's pretty much the same, 0 degrees, 2 degrees, it's pretty much the same. You can see that the lower elevation, generally a little bit higher temperatures, the higher elevation, a little bit lower temperatures in general. We can look at this again. So again, roughly about the same latitude, a little off, but we have some cities one city in China, and then one city, so I think Beijing, and then in Mongolia, and kind of the same thing. So comparing the highs versus the lows, Mongolia, much higher elevation, much lower lows. So I tell you what, let's go ahead and pause there. So that's the first two climate controls, and those are the big ones. Latitude by far the biggest control. Elevation's right there though. But then there's all these other things that we want to consider. All right. So let's pause here, and then the first thing that we'll come back talk about are ocean currents and how those can affect climates in a region. See you back here in just a second.